Imagine looking at a magnificent house and realizing you can only see the paint, the walls, the foundation, and the roof. But the true structural weight holding it all together is completely invisible. That is our universe. For thousands of years, the entire field of astronomy was dictated by a profound limitation. We believe the universe was entirely dictated by what we could physically see. We spent centuries merely studying and cataloging the light. But it took a staggering, paradigm-shattering ontological shock to force humanity to accept that the dark, the invisible stuff, is actually what is holding everything together. And the woman who proved it, the woman who exposed the invisible scaffolding of the cosmos, had to tape a paper skirt to a bathroom door just to be allowed to do her job. Welcome to Legendary Lives Unveiled. If you find yourself captivated by the shadows of the past and the untamed brilliance of those who deciphered the universe, please take a moment to like, share, and subscribe. Your support is the vital energy that allows us to keep bringing these hidden histories to light. Today, we are taking an extensive journey into the multidimensional life of Vera Rubin. To truly understand her profound duality, we must examine mid-20th century astronomical records, deep university archives, personal biographies, and even highly controversial news reports from this very year. Her story is one of an absolute outsider, someone actively and explicitly pushed away from the scientific establishment, who managed to revolutionize our understanding of reality while fighting the crushing terrestrial gravity of institutional sexism. It is a relentless pursuit of seeing what is actually there versus what society tells you is there. But to find the invisible, one must first become fiercely obsessed with the visible. For Vera, that obsession ignited right out of her childhood bedroom window. Born Vera Florence Cooper in Philadelphia in July of 1928 to Jewish immigrants, she moved to Washington, D.C. with her family when she was about 10 years old. In the late 1930s, the residential D.C. night sky was a visceral, looming presence, unmarred by the heavy light pollution of today. She famously stated that she preferred watching the stars track across the sky from her window over actually sleeping. By age 12, she was absolutely mesmerized by the celestial mechanics and shifting patterns. Crucially, her home environment served as an incredible incubator, standing in stark contrast to the hostility she would later face. Her father, Philip, an electrical engineer, actively nurtured her brilliance. He sat down and helped her build a functioning telescope out of a cardboard tube. It was a fantastic foundational lesson in optics, stripping away the intimidation factor by teaching her how lenses work, how focal lengths operate, and how to literally bend light to her will. He even brought her to local amateur astronomer meetings to engage with systematic observers. Her mother, Rose, who worked at Bell Telephone, was an equal force. She fiercely advocated for Vera at the library, persuading reluctant librarians to let this young girl check out dense, adult-level science books. At home, Vera had the tools, the literature, and the parental validation, telling her that her mind belonged in the stars. But when she stepped out of that protective bubble and entered the formal educational institutions of the 1940s, she hit a massive brick wall. The whiplash was incredibly jarring. At Calvin Coolidge High School in D.C., her physics teacher maintained a notorious habit of complete pedagogical erasure, simply ignoring the female students entirely. When Vera won a scholarship to Vassar College and excitedly went to tell him, the designated authority figure advised her to stay away from science if she wanted to be successful. It was devastating institutional gaslighting, like telling a young Mozart to stay away from pianos. But this friction wasn't a bug in the system. It was the mid-century consensus regarding women in the hard sciences functioning exactly as designed. The gatekeeping was an active mechanism. Vera pushed forward to Vassar anyway, a brilliant choice due to its vital institutional memory of female scientific achievement. Vassar carried the legacy of Maria Mitchell, the first widely recognized professional female astronomer in the U.S., famous for discovering a comet in 1847. That historical ghost meant the architecture of the department was built on the premise that women could look through telescopes and make real discoveries. Yet, her day-to-day reality remained incredibly isolated. When Vera graduated in 1948, she was the sole astronomy major in her entire cohort. Just her. Nobody else to bounce ideas off of or study with late at night. She carried it all alone. The hostility of the broader academic world was waiting for her the second she tried to take the next step. She applied to Princeton University for graduate school to study astrophysics. Princeton's response was a total unyielding exclusion. They didn't just deny her application. They flatly refused to even send her a course catalog, bluntly informing her that the astronomy graduate program simply did not, under any circumstances, admit women. Shockingly, that specific ban at Princeton lasted until 1975. Entirely shut out of the Ivy League boys' club, Vera refused to stop. She pivoted and enrolled at Cornell University. She went there largely because her new husband, Robert Rubin, a physical chemist, was already studying there. Driven by domestic logistics, she accidentally placed herself in a highly explosive environment, stepping squarely onto a theoretical landmine. Cornell's physics department was an absolute crucible of modern scientific thought. She was studying under titans of physics, writing the rules of the modern era, men like Richard Feynman, Hans Bethe, and Philip Morrison. For her master's thesis, working under Martha Starr Carpenter, Vera undertook a massive, tedious data project. She analyzed the specific velocities and trajectories of 109 different galaxies. The baseline assumption of cosmology in 1950 was an isotropic expanding universe. Astronomers believed matter was spread out smoothly and evenly, like a perfectly uniform, infinitely dense fog, expanding uniformly away from everything else, much like dots drawn on an inflating balloon. It was smooth, predictable, and mathematically elegant. But Vera's data on those 109 galaxies shattered that pristine picture completely. She found systematic residual velocities. The galaxies were moving collectively, swirling around an unseen pole in a massive, clumpy directional movement. She was detecting one of the very first observational hints of the supergalactic plane, mapping out a giant river of galaxies and proving the universe was messy in texture. She took this inflammatory finding to the American Astronomical Society meeting in December of 1950, and the context of her presentation is agonizingly cinematic. She was 22 years old and exactly 3 weeks postpartum after giving birth to her first child. Having no car, her parents and her husband drove her through a treacherous, blinding snowstorm across icy New York hills with a 3-week-old infant in the back seat just so she could reach Haverford, Pennsylvania. Her advisor had offered to present her paper, titled Rotation of the Universe, under his own name, but fiercely protective of her intellectual labor, Vera flatly refused, telling him, "No, I can go." When she finally stood at that podium before a monolithic sea of established older male scientists to tell them their elegant model was fundamentally wrong, she walked into an ideological firing squad. They absolutely tore into her. The immediate, fierce hostility dismissed her work as sloppy, premature, and wildly overreaching. Her paper was summarily rejected by peer-reviewed journals like the Astrophysical Journal. Only one prominent figure, Martin Schwarzschild, offered her even a sliver of polite encouragement, suggesting her attempt to map the motions was interesting. The vitriol wasn't merely about statistical margins of error. professional male astronomers were deeply professionally invested, their funding and reputations built on the smooth isotropic model. They viewed her as an outsider demonstrating incompetence. The psychological toll on the young scientist was devastating. Internalizing the acrimony, she suffered from intense imposter syndrome, viewing the men as the real astronomers while placing herself in a lesser category. She stepped away from research, later recalling that she would literally cry every time the new issue of the Astrophysical Journal arrived in the mail. The grief was tangible because she missed the process of discovery so deeply, but that grief was about to calcify into an unbreakable resolve. She was about to plunge into the dark ages of academia, and from there, into the darkest, heaviest mysteries of the cosmos itself. That profound grief eventually calcified into an unyielding resolve. She pushed forward to earn her PhD at Georgetown University, working under the famous cosmologist George Gamow. Gamow remains a bizarre figure in this history. Brilliant, certainly, but governing his academic domain with policies that belonged in the Dark Ages. He agreed to be her advisor, but he enforced a strict, non-negotiable rule. Vera was not allowed to actually attend his lectures. The reason? Wives of students or faculty were explicitly banned from the lecture hall. It was the absurd reality of the bureaucratic sexism she had to navigate. Her workaround required mind-boggling physical stamina. While pregnant with her second child, she attended night classes, and out in the parking lot, swallowed by the darkness, her husband Robert would sit in the car, literally waiting for her to finish studying. She completed her dissertation in 1954, and once again, she shattered prevailing assumptions, providing evidence that galaxies weren't just randomly strewn across the void. They actively clustered together in specific zones. But by the time she secured that doctorate, the constant friction had completely exhausted her. She was suffering from theoretical battle fatigue. Cosmology, the study of the origin and overarching structure of the universe, was loud, contentious, and highly aggressive, dominated by men endlessly screaming over the Big Bang versus the steady-state theory. Rubin decided she just wanted out of the crossfire. She sought a quiet, meticulous life in observational astronomy, just pointing instruments at the sky, collecting data on individual objects, and leaving the grand theoretical arguments to the men who wanted to yell at each other. She went looking for a quiet, uncontroversial corner of the universe, but in an incredible cosmic stroke of irony. By trying to avoid the loud debates, she accidentally stumbled onto the loudest, most paradigm-shattering secret in the history of physics. The pivot point arrived in 1965. After a decade juggling part-time teaching and raising 4 children, she walked into the Carnegie Institution's Department of Terrestrial Magnetism, the DTM, in Washington, D.C. She didn't wait for an invitation. She walked right up to the director, Bernie Burke, and bluntly asked him for a job. With sheer audacity, she essentially declared, "I am here. Put me to work." Surprisingly, they did. At the DTM, she formed a partnership with an incredibly talented inventor and physicist named Kent Ford. Ford had just developed a piece of technology that was light years ahead of its time, a highly sensitive image tube spectrograph. To understand the sheer power of this machine, we must look under the hood. A traditional spectrograph takes the light from a star or galaxy and splits it into its component colors, like a highly advanced prism. By analyzing the specific lines in that spectrum, astronomers determine what elements are present and, crucially, how fast the object is moving toward or away from us. But traditional photographic plates were terribly inefficient, capturing only a tiny fraction of incoming photons. Observing the faint outer edges of a distant galaxy required leaving a telescope, staring into the blackness for days just to get a usable exposure, a process prone to severe tracking errors. Kent Ford's image tube spectrograph, however, utilized the photoelectric effect. When faint incoming photons from a galaxy hit a specialized photocathode inside a vacuum tube, they released electrons. These electrons were then violently accelerated by a high-voltage electrical field, smashing into a phosphor screen. This created a much brighter flash of light that could be photographed, acting as an electronic light multiplier. It reduced exposure times from days to hours, allowing them to see the spectra of incredibly faint, distant stars with unprecedented, breathtaking clarity. Armed with this brand new electronic eye, they pointed it at the Andromeda Galaxy, our closest large neighbor, and eventually mapped out the dynamics of over 60 different spiral galaxies. They were measuring a specific metric, the rotation curve. What did the entire scientific community expect them to see? For centuries, orbital mechanics relied on the bedrock of Newtonian physics and Johannes Kepler's laws of planetary motion. In our own solar system, almost all the mass, and therefore the gravitational pull, is concentrated right in the center, within the Sun. Because the gravity is strongest there, inner planets like Mercury and Venus must orbit incredibly fast to keep from being pulled in. Mercury is whipping around the Sun at roughly 29 miles per second. But as you move further away, the gravitational grip weakens dramatically. The outer planets, like Neptune and Pluto, move much slower, with Neptune plodding along at about 3 miles per second. This relationship, fast in the center, slow at the edges, is a fundamental law of physics when mass is concentrated in the middle. When astronomers looked at a spiral galaxy, they saw a massive, blazing, incredibly dense bulge of stars in the center, surrounded by thin, wispy, trailing arms fading into the blackness. Based on the visible light, almost all the mass was in the center. Therefore, the central stars should be whipping around furiously, while the lonely stars at the dim edges should be orbiting very slowly. The graph of their orbital speeds, the rotation curve, was mathematically supposed to spike in the middle and then curve gracefully downward. But when Vera Rubin and Kent Ford processed the data from that state-of-the-art spectrograph, the graph did not curve downward. It was an anomaly so glaring, they initially thought they had made a mistake. They found what we now call flat rotation curves. The stars floating out in the dim periphery were moving just as fast as the stars packed tightly into the bright center. The line on the graph stayed completely, impossibly flat. From a physics standpoint, this was utterly terrifying. Imagine a spinning merry-go-round. If you have someone hanging off the very outer edge and spin it incredibly fast, the centrifugal force will violently rip them right off into the air. If the outer stars in Andromeda were moving that fast, and the only gravity holding them back was the mass of the visible stars, the math proved it wasn't strong enough. Those outer stars should be violently flung out into deep space. The entire galaxy should literally unravel and fly apart. Spiral galaxies shouldn't even exist. They should be transient explosions scattering into the void, but there they were, holding their shape perfectly. Newtonian physics wasn't wrong, which meant there was only one logical conclusion. There had to be a massive, unseen, undetectable source of gravity pulling on those stars. A colossal, invisible halo of mass completely enveloping the galaxy. When Rubin ran the numbers, the math dictated that this invisible matter must outnumber the visible, glowing matter by an astounding ratio of 10 to 1. She created a haunting, beautiful analogy. The visible matter, every star, every glowing nebula, everything we have ever looked at, is just the visible froth floating on top of a massive, invisible ocean. It was a deeply humbling reality. Rubin forced the community to accept that roughly 85% of the universe's matter simply does not interact with electromagnetism. It emits no light, reflects no light, and absorbs no light. It is entirely, permanently dark, Now, to honor the strict historical record, Rubin was not the first to string the words dark and matter together. In 1933, a brilliant, highly eccentric Swiss astrophysicist named Fritz Zwicky observed the Coma Cluster, a massive swarm of thousands of galaxies bound together. He measured the velocity dispersion of the galaxies and found they were zipping around way too fast, concluding there must be dunkel materie, or dark matter, holding the cluster together. But Zwicky's work was largely ignored. The system he observed was chaotic and incredibly messy, filled with complex dynamics and huge margins of error, allowing critics to dismiss it easily. Rubin and Ford, however, provided something entirely different. They analyzed individual, pristine, elegant spiral galaxies, where the kinematics of a rotating disk were mathematically simpler and cleaner to model. Ford's spectrograph provided irrefutably precise data. Rubin didn't just point to a messy blob. She mapped out a hyper-accurate, star-by-star mathematical proof that the laws of physics demanded dark matter as a fundamental, universal component of every single galaxy. She had gone to the DTM for a quiet life, but found herself sitting on data proving 85% of the universe was missing. Her absolute devotion to observational truth left her no escape. She and Ford spent months alone in their offices, staring at flat rotation curves, literally trying to find errors in their own work. They wanted the data to be wrong, but the geometry clicked. If a massive sphere of dark matter completely engulfed the galactic disk, the uniformly spread mass would perfectly equalize the gravitational force, creating those flat orbital speeds. The observational evidence was an impenetrable fortress. Once the dam broke, her discoveries kept revealing a violent, chaotic universe. Later in her career, she mapped NGC 4550, a spiral galaxy in the Virgo cluster. To her astonishment, half of the stars in its disk were orbiting clockwise, and the other half were orbiting counterclockwise, within the exact same intermingled physical space. It was a traffic jam on a galactic scale, providing concrete observational evidence for the theory of galaxy mergers. It proved galaxies actively collide, cannibalize each other, and merge, leaving opposing stars trapped in a single gravitational well. She had uncovered the hidden massive scaffolding of the cosmos. But her journey was far from over. Uncovering dark matter was hard, but forcing the astrophysics community to treat women as equals would prove to be just as much of a grueling, physics-defying battle. While she was literally forcing theoretical physicists to rewrite the laws of thermodynamics and gravity, she was simultaneously forced to physically redesign the architecture of the observatory she worked in. In 1965, the exact same year she arrived at the Carnegie Institution, she hit another historic milestone. She became the first woman officially authorized to observe at the prestigious Palomar Observatory in Southern California. Palomar, in 1965, was essentially the Mount Olympus of telescopes. It was a gilt-edged, carved pillar man cave, an exclusive fraternity for the world's most elite researchers. Women were simply not permitted to look through the eyepiece. And even when Rubin's undeniable brilliance finally forced them to grant her access, the institution still attempted to push her out using the most banal bureaucratic excuses imaginable. The staff explicitly warned her that her time on the mountain would be severely limited. And the reason they gave? The observatory building simply had no women's restrooms. It was entirely outfitted with urinal-studded water closets. It was the ultimate lazy institutional defense mechanism, a calculated move designed to make her feel like a physical burden to the facility. Most people would write a strongly worded letter or quietly suffer. What did Vera do? She bypassed the bureaucracy entirely with a stroke of brilliant, undeniably practical activism. She went to her dormitory room, took a piece of paper, and cut out the shape of a woman's skirt. Marching right back to the observatory floor, she walked up to the bathroom door, taped the paper skirt squarely over the male stick figure on the sign, turned to the staff and declared, "There you go. Now you have a ladies' room." And then she turned around and went right back to her telescope. It was humorous, yes, but underneath that humor was a core of absolute, unyielding refusal to be denied physical space. It was a statement. I am here. My biology is not an inconvenience, and I am not leaving. If we step back, her activism functioned incredibly similarly to the dark matter she discovered. She was an invisible, relentless, unyielding gravitational force that slowly, inexorably, pulled a stubbornly static scientific community toward equality. She used her gravity everywhere. In 1972, she was invited to speak at the Cosmos Club in Washington, D.C., a highly elite social club for intellectuals. But the club had a rule that women were not allowed to walk through the front door. They had to enter through a side or back entrance. Vera flatly refused to speak. She would not lend her intellectual capital to an institution that degraded her physical presence. Her advocacy was also deeply systemic. She terrified conference organizers. If she received an agenda for an upcoming astrophysics symposium and saw an all-male speaker list, she would immediately pick up the phone, call the organizers, and demand they fix it, refusing to let them retreat into the excuse that they couldn't find any qualified women. She also co-authored a devastating, heavily researched report in 1973 for the American Astronomical Society. It detailed the statistically dismal status of women in astronomy, the lower pay, the lack of tenure, the outright exclusion. She pushed for the creation of a permanent standing committee to demand practical policy changes. Her guiding philosophy was summarized in a simple, scientifically undeniable statement she repeated often. Worldwide, half of all brains are in women. Yet, despite her relentless pushing and her monumental success, the agonizingly slow pace of change took a massive emotional toll. In 1981, she was elected to the National Academy of Sciences, a massive honor, as she was only the second female astronomer ever elected in the Academy's entire history. But she didn't view it as a victory lap. She viewed it as a mandate to fight from the inside. Year after year, she nominated brilliant female scientists, and year after year, the Academy rejected them in favor of men. She fought bitterly with them, furious over their persistent failure, later referring to this exhausting battle as the saddest part of her life. She famously lamented, "30 years ago, I thought everything was possible." You can physically feel the exhaustion in that quote. To fight the universe's mysteries during the day and fight institutional misogyny at night is a monumental load to carry. While she was fighting these deeply public battles, she was simultaneously building an extraordinary personal life that completely shattered the stereotypes of her era. Her marriage to Robert Rubin lasted over 60 years, a testament to an incredibly rare egalitarian partnership. As Vera's observational research gained global prominence, Robert fundamentally shifted his own priorities. He didn't let his ego get in the way of her historical trajectory. Instead, he took on more domestic responsibilities so she could maintain a grueling travel schedule, flying out to massive observatories in the mountains of Chile, the deserts of Arizona, and California. Together, they built a home environment that functioned almost like a mini university. All four of their children, Judith, David, Carl, and Alan, went on to earn PhDs in either the hard sciences or mathematics. It completely, irrefutably destroyed the pervasive 1950s myth that a woman couldn't be a premier, globe-trotting scientist and a highly devoted mother at the exact same time. She was also a woman of profound faith, a devout Jewish woman who found absolutely no conflict between her groundbreaking scientific discoveries and her religion. She articulated a nuanced view, viewing religion as a moral code and science as the mechanical tool to understand our physical role in the universe. Her ability to synthesize these distinct realms was respected globally. She was even appointed by the Pope to serve on the prestigious Pontifical Academy of Sciences. But this vibrant life also contained chapters of profound, devastating tragedy. Her eldest daughter, Judith Young, essentially followed in her mother's footsteps, becoming a brilliant, highly decorated astronomer in her own right. Judith won the prestigious Maria Goeppert Mayer Award for her pioneering research into cold gas and star formation within galaxies. She was collaborating with titans in the field, expanding the family legacy, until she was diagnosed with multiple myeloma. After a grueling 8-year battle with the cancer, Judith died in 2014 at the age of 61. The emotional weight of watching your brilliant child achieve so much and then having to bury her is simply unfathomable. This loss was preceded by the death of her husband, Robert, in 2008. She had outlived the love of her life, and she outlived her star daughter. The grief she carried in her final years was immense, and this deep personal grief was sharply juxtaposed against the scientific community's most infamous, glaring professional snub. Because despite fundamentally rewriting the laws of the universe, despite winning the National Medal of Science in 1993, and despite winning the Gold Medal of the Royal Astronomical Society in 1996, making her the first woman to win it since Caroline Herschel in 1828, Vera Rubin was never awarded the Nobel Prize in Physics. This specific omission remains a point of intense, highly charged debate within the physics and astronomy communities today. Prominent modern physicists like Lisa Randall have publicly and repeatedly called the Nobel Committee's failure to recognize Rubin a glaring, undeniable oversight driven by systemic, entrenched gender bias. The observational proof of dark matter literally revolutionized our concept of reality, spawning entire new subfields of astrophysics, particle physics, and quantum mechanics. So, what exactly was the Nobel Committee's excuse? Why did they deliberately pass her over, year after year, decade after decade, until she finally passed away in 2016, permanently rendering her ineligible? The justifications provided by the committee and the staggering hypocrisy hidden beneath them sparked a firestorm that would eventually spill out of the scientific archives and directly into the brutal arena of modern political culture wars. When pressed on this, the justifications from the Nobel Committee and its defenders usually center around two specific arguments regarding the philosophy of the prize. First, during a rare Q&A session, a representative of the committee once suggested that the history of the discovery of dark matter was convoluted. They argued that it involved theoretical whispers from Fritz Zwicky in the 1930s, radio astronomy data in the 1960s, and Rubin's optical data in the 1970s. Because the Nobel rules strictly limit a prize to a maximum of 3 individuals, they claimed it was too difficult to single out who actually discovered it. It was a completely convenient bureaucratic dodge. The second, more pervasive argument is rooted in the fundamental tension between observational physics and theoretical physics. The argument claims that the Nobel Committee is historically reluctant to award a prize for discovering an observational phenomenon when the underlying physical mechanism hasn't been identified. In other words, because particle physicists have not yet isolated and identified the specific subatomic particle that makes up dark matter, whether it is an axion, a WIMP, or something else, the committee felt they couldn't award a prize just for proving the gravity is there. But we must push back on that second excuse immediately, because the hypocrisy there is staggering. Let us look at the historical record. In 2011, the Nobel Committee awarded the Physics Prize to 3 men for the discovery of dark energy, which is the mysterious force that is causing the expansion of the universe to accelerate. We have absolutely no idea what dark energy is. We do not have a particle for it, and we do not have a quantum mechanism for it. It is completely 100% mysterious to this day. Yet, they awarded the 2011 prize purely for the observational discovery that the acceleration phenomenon exists. Why was the unknown mechanism? Excuse wielded like a weapon to disqualify Vera Rubin's dark matter, but completely and conveniently ignored when it came time to award men for dark energy. It is an absolute, undeniable double standard. The inconsistency in how the Nobel Committee applies its own unwritten rules is glaring, and it disproportionately seems to affect women. Many advocates and historians argue that Rubin and Ford's 1970 paper on Andromeda was the definitive, undeniable turning point that convinced the global scientific community. It was a clear-cut textbook case for recognition. But what is truly remarkable is Vera Rubin's own perspective on this glaring slight. She didn't spend her twilight years consumed by bitterness or campaigning for the prize. She was incredibly grounded. She constantly told her colleagues, her students, and her mentees, "Don't worry about prizes and fame. The real prize is finding something new out there." She derived her worth from the cosmos, not from a committee in Stockholm. She passed away on Christmas Day in 2016 at the age of 88. But her name, her data, and her legacy are still the subject of fierce ongoing battles today. Which brings us out of the historical archives and right into the present moment. Because her legacy has been permanently immortalized in massive steel and glass. Yet simultaneously, it has become a fresh casualty in modern political culture wars. Between 2019 and 2020, a monumental historic decision was finalized. The Large Synoptic Survey Telescope, a massive flagship astronomical project heavily funded by the National Science Foundation and the Department of Energy, located high on a mountain peak in Chile, was officially renamed the Vera Rubin Observatory. The significance of that cannot be overstated. It is the very first U.S. national observatory ever to be named after a woman. The scientific mission of this specific observatory is poetic in its perfection. Its primary goal is to map the universe in unprecedented detail, to capture the deepest mysteries of dark matter and dark energy. It is quite literally designed to continue her life's work, a perfectly fitting tribute to her scientific mind. But her legacy as a social pioneer has recently sparked significant friction. Just this year, in 2026, an investigative report published by ProPublica uncovered a controversy surrounding the official federal webpage for the Vera Rubin Observatory. The site had originally featured an extensive biography of Rubin. This biography detailed not just her groundbreaking flat rotation curves, but also her lifelong aggressive advocacy for women in the field, her fight for restrooms, her badgering of conference organizers, and her AAS reports. According to the investigation, the federal webpage was recently quietly altered to aggressively omit references to diversity, equity, and inclusion, or DEI. Passages that explicitly stated Rubin advocated for women in science, sentences noting that science during her era was heavily male-dominated, and specific quotes of hers emphasizing that more minds participate in science were scrubbed from the site or heavily stripped down. The rationale provided by the new federal administration directing these changes is rooted in their broader policy approach. From their perspective, these specific initiatives, terminologies, and focus on systemic exclusion represent a woke ideology. The edits were ordered to remove what the administration perceives as modern political bias from federal taxpayer-funded science platforms. Their stated goal is to ensure that the focus of the biography remains strictly and objectively on her mathematical and observational scientific achievements without applying a modern, politically charged framing to her legacy. Conversely, the advocates, historians, and scientists who knew her, like her biographer Jacqueline Mitten, argued that Rubin would be absolutely furious about these specific redactions. Their argument is that you cannot separate the scientist from the advocate. Fighting for inclusion and fighting against systemic barriers that tried to keep her out of the observatory was just as much a fundamental part of her life's core mission as measuring the velocity of Andromeda. To them, removing the context of her sexism battles essentially erases a fundamental historical truth about who she was, what she endured, and what she stood for. From a broader sociological perspective, it reveals a fascinating truth about our present moment. When a historical scientist's biography becomes a proxy battleground for modern culture wars, it demonstrates that the exact same systemic forces, cultural debates, and institutional frictions that Rubin was personally navigating back in 1965, questions of who gets access, how representation matters, and how institutions should present their history, are still highly active, deeply sensitive, and completely unresolved today. The irony is just staggering. A woman whose entire career, whose entire legacy was built on uncovering massive things that are completely invisible to the naked eye, now has critical parts of her own life story and biography being rendered invisible by the government. It perfectly highlights the eternal tension between an objective, scientific legacy and the deeply subjective social history of how that science was actually achieved. Rubin's life proves beyond a shadow of a doubt that the two are rarely, if ever, perfectly separate. Her path to the science was fundamentally shaped by her exclusion from the establishment, and her ultimate inclusion in the history books was demanded solely by the undeniable, sheer brilliance of her data. It is an incredible, sprawling journey. We have followed her from a curious little girl looking out a bedroom window into the DC night sky, to a fiercely determined young mother navigating a blinding snowstorm with a newborn just to be heard, to a relentless, practical advocate taping a paper skirt to a men's room door, to an absolute legend who fundamentally reshaped the architecture of the cosmos. She forced humanity to reconcile what is easily observable with what is mathematically true. She proved that the universe is far more complex, far heavier, and far darker than it appears on the surface. And she did it not through loud theoretical posturing, but through quiet, sheer, unyielding observational persistence, which leaves us with this final provocative thought to carry with you. Every single time you step outside at night and look up at a glowing, sprawling city skyline, or gaze up at a brilliant starry night sky, remember that 85% of what is generating the gravity to hold it all together is completely invisible. The bright shining lights are just the visible froth, and perhaps that profound cosmological truth translates perfectly to us as human beings. Perhaps the most deeply important parts of our own lives, the unseen, quiet support of our loved ones, the hidden, untapped potentials we carry inside us, the quiet, daily struggles we endure that nobody else sees, are our own personal dark matter. The things we cannot see, the things that cast no light, are exactly what keep us from flying apart. The invisible architecture applies just as much to the depths of the human experience as it does to the swirling edges of a distant galaxy. If you enjoyed this exploration into the invisible architecture of the cosmos and the life of the woman who found it, please take a moment to like, share, and subscribe to Legendary Lives Unveiled. Your continued support is the vital energy that helps us bring more of these incredible, world-changing stories to light. Keep looking up, and always keep looking deeper.